Hey YouTube, thanks for tuning in. I'm about to go through a WingtraOne workflow for getting 3 different deliverables, land XML, an LAS, and an Ortho Tiff. So if you like these videos, hit the subscribe button on my YouTube channel. I'd appreciate it. My basic workflow for my WingtraOne, it uses an RX2 42 megapixel camera. I'm collecting static data with an R10, a Trimble R10 base, and I also shoot some ground control shots for sanity checks on my data. And as you'll see, I have kind of a uniform folder structure through the whole process to aim me in the next direction to make sure that I know, since this isn't straightforward, that I'm going in the right direction. Okay, so let's dive in. I go in and I create, these are blank folders. From there, create my project folder. I navigate to my Wingtra pilot project, and then I'll copy my flights over, put those into my raw folder, and then from my data collector for my Trimble unit, I paste my files, which has my base, and you won't see these, but basically it'll have a TO2 and a little TO2 if you have static enabled during RTK. It's not important. So first things first is to get some of this data going. I'm going to use Opus. So what I'll do is I go in and I'm going to convert to RhinoX, and I open up the TO2 file. There's a couple things in this convert to RhinoX dialog box that is really important, and one of them that I highly recommend writing down is this. This is your ARP offset up in WingtraHub, and then this will need this to process on Opus. So I'd highly recommend writing those down for each project and then hit convert. Okay, so once it's been converted, you can go ahead and close that. It's important to note that I log data at a 1-second interval for this Wingtra dataset. Once you get onto the online positioning, then you go ahead and choose your file, choose the O, open, choose the TRMR10 is mine with no submodel, the meters above the mark, which we just got out of that convert to RhinoX. And if you missed it, then you can go back into convert to RhinoX, put in your email. Once you put in your email, then if you're above 2 hours, then you upload to static. If you don't have the convert to RhinoX, you can go ahead and download it from the Trimble site for free. Okay, while you wait on that to come back from Opus, you can go ahead and open Trimble Business Center. I'm running 5.81. After it loads, I'm running in US Survey Foot. I'll assign US Survey Foot, navigate to my coordinate system, change it, select my coordinate system that I'm using with the geoid, and note that this is NAD 83 2011, Epoch 2010, and that's the Molodesky, and I'm also assigning a geoid model. Okay, that last step was super important to get right, because if you don't have your grid coordinate system set up, then basically you're gonna fight this process. So let's go ahead and name this. So I'm naming all mine with the date 23/01/16 and the initials of who's processing it. Once set up, this is officially a grid project. You'll drag and drop your job file into here. Keep the existing project definition because we just set it up the way we wanted it. In my case, I have some Aztec points, so I'll go ahead and convert them, delete them, and recompute my project. After that, I will cull out any points that were just stakeout points. Now I'll switch back over and I'll grab my opus, print it out. I just put this into my deliverables folder and with the same date and usually the initials, but I guess I forgot. But this is going to be super important, so notice how this is our datum that our Trimble is based on. This is the one that we want to use for our Wingtra and everything else. So we're going to go ahead and correct our TBC first. So copy, navigate to, this is your base point, expand it, go to your global, paste in your new coordinate, go back. Basically rinse, wash, and repeat. Just make sure that you have the correct west or east designation. And then this is kind of a cool trick that you can do to get from meters to feet. So just type M afterwards and then hit tab and it will convert it automatically. But yeah, just make sure you have north and west designations correctly in there, and then I switch to a control quality and recompute. Okay, so now we can open up your WingtraHub, switch over to Geotagging, select your project, Wingtra projects folder. Mine's a raw folder. Check the data sets that you want. I had 2 flights for that day. And I'm going to work with the top. I don't want to output my geotagged. I want my base files. Navigate into where those are. Add them. Select your base location is going to be from the opus solution. So this can go ahead and get name. I like to always grab my global values from TBC, just personal preference. And if you're like me and you probably already closed your solution or your opus solution, then you can just change over to meters here real quick. Grab your meter and your global. This is your ellipsoid height. Global is your ellipsoid height, always remember. And then grid is your orthogonal, or ortho height, basically. I don't know the proper name for it, but basically paste it in. We're going to specify the antenna offset up. And again, if you're like me, go back in, open up your TO2, grab your ARP offset, and paste it into the antenna offset up. So in my case, I also need to include this 0.349 for my APC to the basically the R10 extension. And once you've included everything that you need to, just quickly go up top and verify that you're in the correct latitude and longitude designation, correct meters look right, and your APC AR, and your antenna offset up are correct. And then you save it, and you can select it. Once you have your position, you can apply to all, and we don't want to output geotag or the tagged images. We just want a CSV. While you wait, it's always a good idea, switch back to your survey foot. Make sure your project is back at grid. You can check to see where your project is. If you have a site calibration, you can check there. You have a local site, there should be numbers in here, and it says use ground coordinates, should be checked. I will be converting to ground after this, but in the meantime, I'm going to do some sanity checks, and I'm going to shoot out a PNAZD CSV. So I'll go ahead and select my points. I want to include as checks, and I'll put them into the deliverables folder. On a side note, you should probably put grid or ground, whichever one you just shot out, so then you don't get confused later. Okay, now that the Wingtra project is finished, it should say how many images were tagged, and hopefully you get 100% fix. And then you can click done. The next step is to open up your Pix4D mapper. I'm going to go ahead and do a new project and browse to my project folder. Again, I give it the date, which is actually 23/01/16, and my initials for who's processing it. Add all my images. With a multi-flight, you'll have to go into your Wingtra pilots folder, get into your flights, images, select all, add again, go to the next one, images, select all, and now everything is in there. You can click next. Give you a warning that nothing had geotags because we didn't output geotagged images. We're going to edit our coordinate system and go to advanced, and this height above geoid is going to be 0. Again, I just make sure that everything matches from my opus, and you saw that in the TBC where to find that. So I'm 0 offset above my ellipsoid now. Now it's time to tag images. For Wingtra, it's latitude, longitude, altitude. Do that for all your flights. Check to make sure that all of your images were geotagged. Once you're happy, click the next button. In my case, I'm going to be using feet, and I need to use a specific Wyoming West Central. Again, I'm always making sure that I'm choosing 2011, and in this one I don't need to specify any other coordinate options. Just hit next. I'm going to select 3D models, and I'm going to uncheck the start processing now. Okay, in your processing options, you can go over to initial processing. If you don't have this tab, just go ahead and check advanced. Then we want accurate geolocation and orientation, and this matching. I like to enable my geometrically verified matching. Basically, after that, kind of leave the defaults. I do want some Google Maps generated from this, just as a side thing. I'm going to go ahead and use my full RAM and threads. So that is pretty much it. Hit OK and uncheck 2 and 3 and start. Okay, so while we wait for this to do its thing and process this data set, we can go ahead and come over and bring our project to ground in TBC. So this project will be based on a local ground point and our local point, and it's off of my 1001 point that I did. So I'll go ahead and set these settings to bring it to ground. This is the ground scale factor that I'll be able to use to bring this back to grid. And once it's assigned, just hit OK. And now we are at ground. The way that we can tell this is we can do an inverse command between a base point and a point that's far away. Our grid distance, 4952, should be the same as our ground distance, 4953. So we are 7 or 8 thousandths of a foot difference over almost a mile. So I would say that the grid and ground distance is pretty good. If we did not bring it to ground, I just undid my ground projection, so I'll go ahead and do the same inverse. Now the grid distance is 4809 and the grid distance is 4809 and the ground distance is now 49.5. So there's a little over a foot over a mile at my latitude in error over a mile from grid to ground. And trust me, people and their properties would notice a foot missing from their property. What you end up doing is you can draw a polyline from 1001 to whichever point that you want, and you can establish a ground distance. Let's go over. Now I just make a copy of it. And then you can apply your scale from your ground scale factor. In order to get the correct way to do that, you need to do a combined scale factor conversion, so 1 divided by your scale factor. Or your ground scale factor. So in order to get to ground, you have to multiply it by 1.0, so the line should be longer. I just was having a brain fart. Put an equal sign. Change your, so you can copy that, and you can paste the values only. Format it so you get enough decimal places. Copy that. Okay, now we'll scale our grid line. And we should be scaling down. Since our ground scale factor was above 1, we need less than 1. Apply. Close. Now we have our grid line that matches with our grid point and our ground line that matches with our ground point. These can be referenced when our image is built. We can see our targets and we'll be able to scale our image. Our point clouds will be scaled upon import, so we won't have to worry about that. Okay, so after everything has finished on the first step in Pix4D, you'll get a quality report here. You can kind of just look through it and make sure everything looks good. This dataset, the Wingtra datasets are just unparalleled for their camera positions when you say that they have accurate geolocation. The results just kind of speak for themselves, especially after using it and comparing it to survey data over and over and over again. These datasets are awesome. So, but you can always check it. So I like to import my GCPs because I've been burned once or twice by not having ground control points. One flight messed up, and then basically I was left kind of guessing which flight was actually out of place. Luckily I had a bunch of survey points that I was able to see unintentionally, and I was able to correct that project. So highly recommend having these sanity checks and adding them in. It's an easy thing to do. You just shoot a couple points while you're out running around. Make sure that you can see them. Then basically just make sure that the control plane lands where you would expect it. This is without touching it. This is with the grid because I processed everything at grid. So my ground control points that you're seeing are at grid on import. And so if your data sets come in correctly, you don't need to touch them, then you can run steps 2 and 3. If you do need to actually reference your ground control targets, this is when you do it. And if you have to reference them and you're going to be working at ground, I recommend just shooting out your CSV in ground and then tagging all of your ground control points, and then you don't have to worry about scaling your ortho. It just makes life a little bit easier, but the TBC transformation of the point cloud is pretty straightforward. Okay, so now that our model has finished processing steps 2 and 3, we can go ahead and save our project. And there's one more thing that I like to do before I get out, is just verify all of my coordinate system that I processed with is going to be what I am bringing it into TBC. One of the options I forgot to mention in geotagging is that you can go over into your WingtraHub and then go over to the Geotagging tab and output a Trimble project file. So after you do that, or if you did that on the beginning step, then you can just navigate into your project and it'll be in your raw for your output. So each flight will have a JXL associated with it. Okay, so during the recording of this video, I actually realized that 5.81 does no longer actually scale your point clouds. And the only reason why I know this is because of my sanity checks. Again, this is one of those times where the sanity checks has saved my project. This would have led to hours of me trying to explain what's going on to the client, trying to scale it, trying to see what's going on. But because I have sanity checks, then I knew that the data set was off as I'm importing everything. So as a workaround, I guess that I'm going to have to scale this project and just to show you what's going on. So if I go in, I'm at ground right now. And if I import my point cloud and tell it what coordinate system it's in, so let's just say for simplicity's sake that it's grid scaled in the project coordinate system. That used to be all that you would have to do in 5.7, and as soon as you'd bring it in, then it works. Okay, so now that it's imported, we can zoom in to the known positions that I have. So this block is supposed to be right on the edge of that concrete block. And if it would have scaled it correctly, it would have been. As you can see on this, there's a lath going across here, and there's a cross here. That's where it's supposed to be. If I were to import the grid point, you'll see that that we shot out earlier. If we import our grid points, the LAS dataset is still at grid. You can see it over here as well. So the edge of the concrete marker is still at grid. So if I wouldn't have had my sanity checks and my visual verification for this dataset, this would have been a fail, and basically it could have cost me, the client could have cost me time. Trimble, I don't know what the heck you're doing. Trimble's not the only one. That's why these sanity checks are also important. AutoCAD gets this same thing going on pretty frequently when they do updates. So if you don't have sanity checks, something to verify your data set against, you are going to have a hiccup like this. Anyways, I will proceed forward with showing you the workaround. So I'm just going to go ahead and undo my import. I have to go ahead and strip my coordinate system, which is not too hard, so just hit OK and verify that all of my ground projection is gone. Now I can re-import that same point cloud. And I'll tell it the same thing, it's grid scaled in the project's coordinate system. Hit OK. Okay, so now that we have everything scaled, when we can go in and verify our point is in the correct position. Yep, it's on the edge of the concrete now because we're in grid now. And yeah, both crosses in the lath are in the correct place. Now, if we bring our project to ground, then it'll receive the correct transformation. So same process as before. Just selecting the project height and latitude, longitude, assign it, hit OK. And you'll see right away that the grid is matching. And then to verify everything is going on correctly. I put in my sanity grid check for the rest of the data sets. And our data is no longer at grid, it's actually been scaled to ground. So in order to do this on a larger scale, again, check to see if you're at ground. You can clear that just by going up and reassigning your coordinate system here. So you change, select you can go in, do this, next, select your geoid, finish, and OK. And in Pix4D, we verified that the grid and this model match by having our pictures and our ground control match. So we don't need to do anything farther than that other than import those files. So just navigate where they're stored. Mine's in the photogrammetry, in the densification, and select all of them. So they are grid scaled in the project's coordinate system. We verified that using our ground control. If that's not the case, you need to select this other toggle, and then you'll select your geoid that everything matched with, and then we'll apply it to the next 11. Okay, so now that you have all of your grid point clouds imported, then you can go ahead and re-put it back at ground. And again, so now I just visually verify everything's correct. You can re-import your sanity checks that were done at grid now that I'm at ground, just to make sure that we are in fact at ground. And yes, our ground scale factor is larger than 1, so it should be longer. So we are ready for the next step. So the next step, expand the point cloud regions. Click on the never classified, or you can just click on the point cloud. And then we'll go into the point clouds module, and we'll extract ground from this. We want to create the region and extract. Okay, now that the ground is classified, you can select it from the point cloud, export it to an LAS in the point cloud module, put it in your deliverables folder. And make sure that you're scaling as ground, and then export. I guess make sure whatever you're going through, so either ground or grid, just match it. As a precautionary note, I will be checking the never classified and ground and exporting those as a single raw LAS, mostly just to check it to see that the ground scaling is working and that the grid scaling is working from the output standpoint. So if you're in the trust but verify like I am, then you can create a region here, and so if you just want to verify the max point cloud here, then you can just select, and then we can create a region, and we'll call this our check region. From the menu on the left, you can select your check region and export it as an LAS. So we're going to go ground first, and we're just going to call this check ground. I'll export that, and turn that back on, go back up to our check, export, and in the option we'll choose grid. So now we can just this. Grid. And save. Export. Now we can bring it in. So naturally, what we would hope for is that these point clouds would receive the correct scaling, and I'm guessing that they're not going to. So we'll go ahead and import our ground first. This one should match, so it's ground scaled in our project coordinate system because we just exported it. You can bring it in. We would expect this one would match. There we go. So we're imported. Make sure that our point cloud came in correctly. And it looks like it did. So the ground scale works there. So now we'll try our grid scale. Grid scaled in the project coordinates. And if it was broken on the last process, then I would expect that this process is going to be broken as well. As a, I guess, now I'm just curious, because I know that that process is messed up, then I'm wondering what happens if I bring in my grid as ground, if it's even going to make a difference. So my theory is that it's not applying any transformations to the point cloud, and if it shows up correctly, then it kind of confirms my theory. Okay, so yes, it's confirming my theory that the export is also not receiving any transformations. So make sure that you're aware of this. If you're going to bring in a grid, make sure that your project is at grid. Import your point clouds, then bring it to ground. Your exports will be at ground unless you transform back up to grid and then re-export your point cloud from the same thing. And just to show, I shot it out as ground, so none of their scaling on their point clouds is working. Beware any TBC user of 5.8. It was working in 5.7. I can't say what happened in 5.8.1. Okay, so now that we have our sanity checks completed and we've basically just over-analyzed everything, then we can move forward with the next process, which is turn our ground points into a surface but first, before we do that, we need to sample by region. I'm going to go ahead and create a 2-foot ground sample and store it. Now that that's stored, we can select it from our regions over here, and we can create our new surface, name it appropriately, apply it. After it's been applied, you can go ahead and close your surface, select your surface, and then you can export that to a land XML. This is directly importable into Civil 3D. So again, I'll call it a 2-foot ground sample. And this is going to be at ground scale, so G&D scale. Save and export. Something that I actually really like doing that produces a cleaner surface is actually doing the next, is building a DEM using QGIS. And the way that you would do that is you actually start by using Cloud Compare. So I recommend this Cloud Compare. It's a really awesome program for being able to make really nice looking data sets. So I'll select my ground LAS. I have all of my ground classified points, and I'll apply, and I'm going to get my shift from my input. While that imports, I can show you how to do a points to surface comparison. Okay, once imported, you can go into Tools, Projection, Rasterize. I first take a 1 foot sample and I'll choose my Z direction, and I'm going to choose minimum value, and I don't want to interpolate currently, so go ahead and hit update. Yes, I want to generate it. So as you'll see, any gaps are not filled during this process, and that's exactly what we want. So I'll go ahead and hit the cloud export. Now we can use this export, and we can go into our projection again. This time we're going to do an averaged, and we'll go ahead and do a 5 foot averaged surface. This works pretty good for large data sets like this, and then we'll interpolate it. The maximum edge length that I want is going to be anything less than 30 feet. And my cell value, I want to be able to detect if it did not interpolate it. So I'll do a minus 5,000, and this will make it easy to clean my data set afterwards. So I'll update my grid, export my cloud, okay. Click on this. You can then get over into a little bit different view and use your scissor tool to snip off the stuff that didn't get interpolated, clip it in, delete the clipped in part, and then basically if you hit 8 on your keypad, it'll bring you back to a top view, and we're starting to look pretty good. So now we can hit our edit, tools, projection, rasterize. Go ahead and leave that the same, leave it empty this time, no interpolation, update, and we can just check to see how our contours look. This builds really nice looking smooth contours, and basically you just do 220, one every 1 foot, just to see what it looks like. You can take a maximum roughage value. I like to use a 50 count, but 25 on a 5 foot data set is also pretty good. So generate, and now you can see our contours do a really good job on this data set to help clean up this data. So we'll go ahead and export. Okay, so you can, right now you could hit save as a DXF, and that is directly importable into CAD. That's not actually what I want, so I'm just using it to check. So you can go to rasterize, we'll leave it empty again, and this time we'll just do a raster. We're going to export the heights only, and we'll hit OK. And then what we can do is we'll put that into our working folder, which is actually going to go into my raw. You'll see why in a second. So this is, name it, and save. Oops. In QGIS, we'll go ahead and get our project set up. Same thing with our Wyoming, or with your projection that you need. And click apply, and OK. And now we can go ahead and import from our raw folder. We can import our density and our raw. go ahead and assign our coordinate system to both of these two. We're interested in this DEM, so we'll right click and we'll hit Save As. We're going to put it as a GeoTIFF to make sure that this is compatible with AutoCAD Civil 3D. Put it out into our export into our deliverables folder, and this will assign the coordinate system. Go ahead and save, and it's going to shoot out as a TIFF, and then make sure the project coordinate system is the one that you want, and hit OK. That being done, that's all that we need to do. So go ahead and close everything and discard all the changes, and our TVC is good to go, and that is all of our deliverables. Okay, so that's actually not true. I've got to do one more export in TVC, and I'm going to select my grid and my ground. And then I'm going to go ahead and export this as DWG. This will assign the correct coordinates and everything going forward. So you can either do it as a DXF or as a DWG, it doesn't really matter. But so I'll go in and put this into my deliverables folder as well. And this is going to be for my Ortho. So I'll name it Ortho Image Scale Lines and hit Save and Export. Now we're done on the TVC side, we can hit Save. Okay, there's actually one more thing. I forgot to show how to prepare an Ortho TIFF for Civil 3D, just to make it so then Civil 3D can read large data sets like this. Granted, you could use the tiles that Pix4D generates, but what I like to do is I like to downsample my Ortho, and the way that you do that is open up QGIS. You can go into your photogrammetry, into your mosaic, and basically drag and drop that in. So by default, CAD can't actually read larger than 2 GB data sets for an Ortho mosaic. So what I end up doing is I'll just do a sample of this, and I'll change my units to a 3-inch unit. This reduces the time that it takes to load these images, and everything about working with these images gets easier if you do this step. So basically you can leave everything else default and give it a name, then save, and all of these options here should be good to go, and hit OK. Bear in mind that there's going to be a data loss here, obviously, or for obvious reasons. So as you can see, you can clearly see the lines coming across and the crisp clean edges to things, and then when you sample to 3-inch, you can still see what's going on, but it is a consideration for some clients, and if they are alright with using the tiles, then let them. Okay, I also forgot to shoot out my ground points. So go ahead and select those. Once selected, you can hit export, do it into a custom PNEZD, put that out into our deliverables folder. Okay, so if you're like me, you will also prepare a drawing for your client, so they don't have to navigate all these unit settings and everything like that. Even to date, I've used this method multiple times, and I get to get in here. They did an update, and my method has changed. They've changed how the settings are being used and swung around. So from 2018, it was reliable, and then you switched out to 2020 to 2022, and the units are never the same. Almost every time I receive an update, I have to fight this. So again, this is why sanity checks are so important. So we'll go ahead and open a blank drawing with the default units, and then see what units we're in currently. Currently we're in US survey foot, or in feet, not US survey foot. And then I've also created a survey database, and I've assigned US survey foot to that. As far as my drawing settings go, I have international foot, and I'm going to leave that for the map import process. So we'll go ahead and map insert our drawing or our image. Go ahead and create a layer for it. Okay, so if you zoom extents, then we'll get over into our image. Go ahead and put that onto our image layer. And then we can go ahead and insert our survey points after we assign our unit settings. US survey foot, apply, okay. So grid is shorter than ground, and so this is in the right place to start. Next, I'll change my units. To US survey foot for my X reference. Again, all these drawing and unit settings and everything, switching back and forth and knowing when to go into them is completely ridiculous. I've tried to set up a master drawing that I can just use, and it's even less predictable. Every time that they do an update, I am left chasing scales and projections and you name it. Okay, so what I'm going to do is I'm actually going to bind the drawing, and I'm going to insert it. So then I have my grid and my ground lines. The point should reside at the end of our ground if it came in correctly, and then we should have a, oh, that's a block, so I'll just explode it. And now in our layers, should see grid and ground. So my grid is shorter, it's correct. And that's also what we saw in our image. So what I normally do after importing like that is I will lock my grid and ground so I can't scale them. And then I'll just scale my image. My base point, I'll reference my base point again. And select. Okay, so I almost always mess this up the first time, but that's why we have a grid and a ground line. So the red is our grid line and the green is our ground line. Our image is at ground or at grid, so we need to scale it up. So we'll type scale. We'll go from our base point and we'll do a reference scale, and then we'll select our base point again, and then scroll down and select the endpoint of our grid line. Sorry, I'm doing this remotely. And then we'll scale it up to the end of our ground line. And now we just verify that our points are representing our checks, and we find that they do. Next, we'll want to import our land XML, which is the most straightforward. So first, we're going to go into our units. That's survey foot. Our settings for our drawing are at survey foot. And now we can do our land XML import. Go ahead and expand everything, make sure that these are correct, so our unit is good to go. If you get this message, then you just keep the level of display, and then we can go into our settings for our surface and just do our surface style, and we want to see our major and minor, and over in our contour you can specify your contour interval. I want 1 foot high, and okay. These land XMLs that TVC generates are pretty decent. The one thing I will say after doing this for so long is that, again, check everything. Every import that you do, check it. Check to make sure that your road breaks where it's supposed to do. Check to make sure that your control is matching in really well. And in this case, I mean, with the snow on the ground, I really can't ask for much better.